Hello, welcome back to Algebra 1 Lessons with Miss Andrea. And today we are on lesson 5.3. And so this is module 5 online, which got out of order. And in the online book, it's called unit 3. So online, it's out of order, but we're going to stay in order with our videos here. And we're going to call it module 5. And it's page 3 online. So today what we're going to get into is we're going to begin to talk about how to factor, because factoring is going to be an important way to help us find the solutions to some of the quadratic equations that we're going to be faced with. So before we can get into what factoring is, we first need to figure out what are factors. Well, factors are the part of a multiplication problem that creates a product. Remember, we have a factor plus a times a factor makes a product. So 2 times 3 equals 6. 6 is the product. 2 and 3 are both the factors. And just like you can have factors that are multiplied together to make a product that's a number, all of those being numbers, you can do the same thing with polynomials. So you can have a polynomial times a polynomial equals a new polynomial, like we have down here. So x plus 3 times x plus 1 equals x squared plus 4x plus 3. Each of these are factors, and then the resultant, the product of them is, after you multiply them together, is what's on the expression that's on the right side of the equation here. So that's what factors are. So if that's a factor, what's factoring? Well, factoring is undoing that multiplication. We had the problem of 2 times 3 is 6. Well, if you're given 6 and you're asked, what are some factors of 6? Well, you'd say, okay, 2 and 3 are factors of 6, or 6 and 1 are factors of 6. That is factoring. It's the process of undoing the multiplication that was done, finding out the different things that are the factors that make the product. And it's going to happen the same with polynomials. It's basically like taking this long expression and splitting it up into multiple smaller expressions. So what we have here is an example. We're going to factor 2y plus x. And so the easiest way to factor this that we can see, what are some things that can be multiplied together to make this? Well, I can see that they both can be divided by 2. And remember, division is the opposite of multiplication, right? So if I can divide something out of an answer, then that must be one of my factors, okay? So 2y divided by 2, we're dividing by 2, so I'm going to put that on the outside. And then I'm going to create parentheses for my 2 terms, because there's term 1 and term 2, right? So there's 2 terms in my original expression. I'm going to end up with 2 expressions. And this expression inside the parentheses is going to have 2 terms. So 2y divided by 2 is just going to be y. And then positive 6 divided by 2 is a positive 3. So this is 2y plus 6 factored. We have a total of 2 factors. Factor 1 is just the number 2, or the integer 2. And factor 2 happens to be a polynomial, y plus 3. And when we multiply them together, we're going to end up with 2y plus 6. So when we multiply this out, that's called expanding. If we take 2y plus 3 and distribute that 2 to everything inside of the parentheses, that's called expanding. When you go from something that's already expanded down to its factored form, that's called factoring. So you can see that they're just the reverse of each other. And now there's many different ways that we're going to get into learning how to factor polynomials. But what we just did, where we took one number out of each of those terms, we took the terms in our polynomial and divided by a common number. Well, that's one type of factoring, and that's called common factor, right? We're factoring using the common factor. This is when you find a number that every term in that polynomial can be divided by, and we're going to separate it out as its own factor. Usually this means we find the greatest common factor. So if I had the number 12 and the number 4, I want to know, well, what's the greatest common factor in these? Okay, so I've got a 4 times 1 here, and I've got a 2 times 2. Those are both sets of factors of 4. 12, I can find 12 times 1. I can find 6 times 2, and I can find 4 times 3. Well, these are all factors. Well, what are the common factors? Common factors are the numbers that they have in common or are the same in both of them. I can see that 1 is in both of these and 2 is in both of these, right? And then 4 is in both of these. So those are all the common factors. Well, then the other word we have is greatest. What is the greatest common factor? In other words, what is the largest number that they have in common that's a factor? And that's going to be 4. 4 is the greatest common factor between 12 and 4. You should remember that from doing factoring a while ago with numbers. We're going to use that same concept when we factor our polynomials. We want to find the greatest common factor. So let's look at what we have here. Our example, factor 3y squared plus 12y. Well, 3y squared is going to be 3 times y, right? And 12y can be 3 times 4 times y. So let's see what we have in common. They have in common a 3, and they also have a y. So what would our greatest common factor be? Well, if we multiplied those things that they had in common together, 3 times y, 3 times y. So our greatest common factor is 3y. So we're going to take out of these 3y. So if we took a 3y out of both of these, what are we left with? Well, in this case, we're left with y. And then this term right here was positive. See, so we're going to have a positive term here, and we're left with 4. So our final answer is 3y times y plus 4. So the first factor is 3y, and that was our GCF, our greatest common factor. And the second factor is y plus 4. So this is how you factor by finding the GCF, or the common factor, the greatest common factor. So I've got some more examples to do with you, and then on the next page, you're going to try to do it yourself. All right, so here we have 3x minus 18. And it should be pretty easy to determine what the common factor is here, because 3x and 18, well, I can already see that a common factor is not a variable, right? So a common factor has to be 3. Well, in order to check that, I want you to use your calculator. Well, we know 3 divided by 3 is 1, but what about this negative 18 here? Negative 18, so let's do 18 divided by 3. Okay, that's 6. So it looks like 3 divides in evenly from 18. So we can say that 3 is a common factor. So 3x divided by 3 is simply x. And then negative 18 divided by 3, that was my negative 6. And so the factored version of this expanded form is 3 times x minus 6. 3 is one factor, x minus 6 is the second. All right, so let's look at this one right here. This one's going to be a little bit different. Instead of having a number or an integer as our common factor, we're going to just have a variable, because if you look at 4 and 5, the only common factor that they have is the number 1. Well, we don't factor out the number 1 because it's pointless. 1 is a factor of everything. So it's not going to change anything to factor 1 out. But what can we factor out that would change something? Well, if we can't do anything with the integers, let's look at the variables. There's an x and a y here, and simply a y here. That means that y is going to be my common factor. So if I cross out my y's, or you can think of it as dividing. 4x divided by y, that means the y goes away, right? 4xy divided by y. So that leaves me with only 4x plus 5. So my first factor is y, my second factor is 4x plus 5. x squared plus 5x. Again, I'm not going to have a common factor as an integer because there is no integer here other than 1. So that's going to leave me with just some x's, and this is x times x, right? So if I cross out 1x from each term, because I'm going to put it as the common factor, then I'm left with x plus 5. So factor 1 is x, factor 2 is x plus 5. All right, here we go. Negative 2x squared plus 4x plus 2. Okay, well, here we go. I've got 3 terms. Does this change how I deal with common factors? Not really. I just need to make sure there's one more term that I pull my common factor out of. One thing of note here is anytime your first term is negative, your common factor will always be negative. And what that means is it's going to change the sign of everything else in the parentheses. Okay, so I know my common factor is going to be negative. And I'm going to assume that it's 2 here, looking at this, negative 2. But let's see, can 4 be divided by 2 evenly? It can. Can 2 be divided by 2 evenly? It can. So I know that there's going to be a 2 there. Is there a variable in all of these? It's the same letter. Well, there's 2 x's in this one. There's 1 x and there's no x's. So I can't factor out one of the variables. The greatest common factor I can factor out is a negative 2. So negative 2x squared divided by negative 2 is simply going to be x squared, because if we divide out negative 2, that leaves us with x squared. 4x, okay? Well, if we were to multiply negative 2 times what to make a positive 4, it's going to be a negative 2, and then we have an x there as well. So if we cross out one of the negative 2's because we're factoring it out, we're left with negative 2x. And you can see how that positive sign switched to a negative here because of our negative that we're factoring out as the GCF. And then a positive 2. If I'm factoring out a negative 2, it's negative 2 times negative 1, right? So if I cross out what I'm factoring out, the negative 2, I'm left with a negative 1. So negative 2, parentheses, x squared minus 2x minus 1. So our first factor is negative 2. Our second factor is x squared minus 2x minus 1. All right, down here on our last one, this one may look a little bit trickier, but really it's pretty easy. We just have to find what can we take out or divide out of both of these. Well, both of these are being multiplied by x minus 1. So the common factor in this is x minus 1. And if we cross out x minus 1 on both of these, we're left with 3 plus 5y. So this looks a little different because instead of having a single term as our first factor, we actually have 2 terms, a polynomial here as our first factor. So our first factor is x minus 1, and our second factor is 3 plus 5y. All right, it's your turn to try this on your own. Go ahead and pause the video, work it out, and then come back. Welcome back. So let's go ahead and get to it. This is 3 times x times y, and 9 is the same thing as 3 times 3 times y. So let's cross out some things that we have in common. Well, I've got a 3 here and a 3 here, so I'm going to put that over there. And I've got a y and a y, so I'm going to put that over there. And that leaves me with only an x plus only a 3. So term 1 is 3y and term 2 is x plus 3. All right, so let's look at this one. I've got 5 times x times x. This is 5 times 3 times x. And this is a negative 1 times 5 times 5. So let's see what they have in common. Well, each one of these has a 5 in it. So 5, 5, and 5. I'm going to go ahead and put a 5 right there at the beginning as my greatest common factor, because there's nothing else that they have in common. So my first term is going to be x squared. My second term is going to be 3 plus 3x. And my third term, my negative 1 right there, indicates my negative. So this is going to be a negative 3. So term 1 is 5. Term 2 is x squared plus 3x minus 3. Or factor 1 and factor 2, rather. Excuse me. All right, so here we have x times x times x. Here we have -1 times 2. I'm going to just draw a line right there. -1 times 2 times x times x. And I'm going to do this one up here, 3 times x. All right, so something they all have in common is simply going to be just one x. So one of these x's. That's the only thing I see that they have in common. Okay, so that leaves me with 2 x's here, or x squared. And this -1 times 2 times x is going to be -2x. And then this is just a +3 here. So factor 1 is x, factor 2 is x squared minus 2x plus 3. All right, here we go. -1 times 5 times x, and this is simply just 5 times 1. All right, we're not going to take out the ones because that's a -1 and that's a +1. But I do need to have it as a negative, because remember, if our first term is negative, then our common factor has to be negative. So I'm going to have to adjust this in some way to account for a negative that I want to take out. Well, if I change one of these to a negative, and -5 times a +1 makes a -5, so that's not right. So I've got to change both of these to a negative, -5 and -1. If I multiply those together, I'm going to get a +5. So that works. Okay, now let's look at this. I need to, now that they're both negative, I need to factor out my -1. So I'm going to go ahead and put -1 here. I'm going to instead of -1, I want to actually, because I got that 5 in common, I'm going to actually change my negative here to be a -5. -5 times x. So I've got a -5 in common. So -5 and -5. And then I've got 2 x's here, but no x's over here. So what I've got left is x squared, and then my 5, I have left a -1. And just to make sure that that works, we can go ahead and distribute that just to check it. -5 times x squared is -5x squared. And then -5 times -1 is a +5. And we got 5x squared plus 5. So you can see that we were able to re-expand this equation and still get the correct answer. That's how you check your work when you're factoring, is you're going to undo the factoring that you just did, and that's how you check it. All right, so this last one here, 2x times x plus 5 plus 3 times x plus 5. Well, it's easy. X plus 5 is my factor that I see right off the bat right here in both of these terms. So my factor goes first, and then I have another set of parentheses for what's left over in each term. And what's left in the first term is 2x, and what's left in the second term is going to be 3. So factor 1 is x plus 5, and factor 2 is 2x plus 3. All right, I know that you have an assignment coming up. Go ahead and practice your greatest common factoring assignment. I know you're going to do great and get an A on it, and I'll see you at the next lesson.